Right then, so I'm reasonably happy with my tie-clip mic in OBS, etc. We've gone through the basic building of the robot, which you should have something similar to that, with 4 wires going from the 6, 10, 11 and 12 pin on the Arduino straight through to the 4 pins in any order on the L298, and then you should have your 3 sensors plugged in as on 2, 3 and 4, and if you've used this board then you will have your earth and your power coming straight from the board. Nice thing is that oh, and that's the other thing, what you need to do as well is you need to build yourself a little robot stand. Reason being is that to start with, when you're programming, you don't want the wheels on the ground, otherwise you make a programming error, it sets off, pulls all the wheels off, jumps off the table, breaks, and everybody's unhappy. So what I've done is I've built a little stand that all it does is lift the wheels off the ground so that you literally can program, and you can see what your program has done, you can test things, and you're not causing yourself a lot of issues with this thing rushing around the table. Right, so if you've gone and downloaded Arduino, you should have a screen that looks like that, so that when you go into it, it gives you a sketch name, which basically what that does is it just gives it a name. So what we're going to do is start out by renaming that. So what we'll do is save as, and we'll call it table bot 01 for want of a name. So when you loads up, the first thing that it does is it gives you 2 sections automatically, one called void setup, and it does tell you put your setup code here to run once. So what it's trying to tell you is that that piece there runs at the beginning. So if you have got things that you want to set up, particularly things as we get deeper into it, like calling up modules and calling up libraries and calling up, not necessarily libraries, but calling up starts to libraries, initiating libraries, that's where you put them in, because it runs that code once. And then once you've got to the end of that, it then goes into this loop, and it goes round and round and round and round and round and round and round of that until the battery dies or you turn it off. Now then, it's part of the language, it uses the word void, and then it gives it a name, and there are certain names that you can't use because they're already used. Don't worry about them, I'll show you how to get by that so you don't make the mistake, and then void loop. And all that void means is it basically tells you that there's nothing coming back from that loop. You can actually set loops up that send information back, and without getting too deep into it, that's where we will go eventually. But we're left with a situation to start with that we want to start. Let's take this bot here, and we want to find out where everything is. Right, so we need to go in and establish a connection between the bot and the thing. So we'll go in and we'll actually turn the robot on, and then what we'll also do is plug it in to the PC, which you should get the beep that you've connected, and then we'll go back and have a look at the software. Now then, before you can actually start sending software, you need to double check that you've got a connection. So if you go to Tools, you'll then notice that the board is set to Arduino Genuino Uno, which is the correct board for the Uno. There's a lot of other alternative boards out there, and a lot of the different boards is to know how the bootloader works. So if you've got that on Arduino Genuino, and then double check the COM port, which it should show you that it's the COM port that it's on, and if it's not, change it to select whichever COM port it's on. Obviously mine's on 4. And then just as a proof of concept, we'll go over to that little arrow there, press that, it goes yellow, which says that we're actually loading that empty piece of code down. The system will go through its compile, it'll then say it's uploading, done uploading, and the bot has got the software, and the LEDs there will flash as it comes across. Obviously the software says nothing, so it does nothing. First thing we're going to do is we're going to set up what's called an interrupt. So an integer. You type in that, now you notice that's gone green, or turquoise, or whatever you want to call it. That's telling me it recognises that word. Now then, what an integer is basically a little box that we can put a number in. and I'm actually going to call that give that box a name. Now then I start all my variables with the letters my, and I'm going to call it my left. My left forward. And you've got to put a semicolon at the end, otherwise it doesn't understand it. So what I've done is I'm actually going to say equals 6. So what I've done there is I've told it that I want a little box. I want to call the box my left forward, which will relate to what's actually happening with the motors. And in that box I want to put the number 6. Now I'm going to cheat. I'm going to cheat if the mouse will let me. I'm going to copy that 3 times. Get rid of the extra spaces. And then I'm going to rename that to, or retype that to right forward, that to left. Put a K in there, and go in and rename that one to so what we've got is 4 little boxes there, each with a name on the box, and at the moment they've all got 6 in. Now then, the reason I've put 6 is that is the number of the first pin. Now that's one of the nice things about object-oriented languages. You can actually deal with everything as if you take an object. You can say this is, so instead of having to keep putting pin 6 everywhere, when I've found out which is my left forward pin, I can then say my left forward pin is always 6, and then from there on in I could use the word left forward, which is far more easy to understand than keep having to put the word the number 6 in to remember where your pins are. So I'm going to ignore the void setup at the moment, and then I'm going to go into the loop, and in the loop I'm going to put the word digital right, which basically, if you notice that's gone red, it's understood what I've said, and I'm going to say digital right, my left forward high. Now then, what I've told it is to literally, digital right says right a pin high, and I've said right whatever's in box like my left forward, which we know is 6 high. So I've actually told it there to literally turn pin 6 on. Simple as that. And if we actually load the program up, which will go through the compile, we'll load the program up. We can actually see that what will happen is it'll now it's loaded up, and there we go. Now then, that's actually, if I consider that's the front of the robot, it's actually right forward. So we actually, what we know now is right forward is actually pin 6. So what we'll do is we'll go back to the screen, and we already know that right forward is pin 7. So what we'll do then is we'll say pin 6, silly. So that right, do you think? Because it's what they call a craft moment, which is it from age, and it's can't remember a thing. So we know that it's not 6, but we know right forward is 6. So that's correct. So what I will do is now change that to 7, which see the logic catches up with me. So we'll now send it off programming, and if we come back to the bot, the program is compiling the sketch. It'll then upload that, and we're now telling it to switch on pin 7, which does nothing, because we know we've connected it to pin 6, pin 10, pin 11 and pin 12. So if I go back to the Arduino and say, Gary, it wants to be 10, no, or maybe 10. If I now run that, and this is the nice part, that when you get it wrong, you don't blow things up. Let's go back to the model, see what happens if we say my left forward is 10. So in actual fact, pin 10 is wheel right going backwards. So that's not a problem. We'll go back and have a look at this program again. So right backwards is 10. And so by a process of elimination, we're now working out what pin does what. So we'll make it 11. So this time, when we go through the program, it's going to say digital right, my left forward high, which we now have my left forward set as 11. So we'll upload that program. Let's see what that does. So, pin 11 is actually reverse my left backwards. So going back to the program, we now know that that is 11. So by a process of elimination, that should be 12. And if we run that program, yep, so we now know that we've got each of those motors set out. So if I now go back to screen, we now have all our motors set out. So we now know that if we say, give it the command digital right, left, forward, high, then it will automatically set that motor going. So what we'll do now is we'll add a little command called delay, and we'll say 1000 milliseconds, which gives you an idea how fast these things run. And then what we'll do is we'll take that command, make life easy for us. Well, we'll take both commands, make life easy for ourselves, copy them, and we'll just prove the point by changing that to low. So if I now upload that program, so what we can do, I apologize, should have switched over a bit sooner. What we can do is we can now see what that looks like in the arena. Have we programmed a clever robot? So I think the simple answer is that no, at this stage we have not programmed a clever robot, but we are starting to get controls and we are starting to get the robot moving and getting it doing things. So we'll plug it back into the programming board and over to the programming. So we've now got that. So we worked through and identified each of our motors, and the program is running now is the little high-low for the left motor. If I change that to right, whoops, to right forward, what it would do is, we'll have a look. So in comes the program. And so what's happening now is the right motor is going forwards, but it's locked on. Because we've turned it on, but because we haven't altered the bottom one, we haven't turned it back off. So if we want it to go back to, we must also have the same command in the bottom. So now the program's working. So we're going to go in now and let's work out where our switches are. We'll start out by creating an integer. Oops, mister. Create an integer for us left switch. Copy that. Copy it again. We'll leave a space between the two, just nice, and it helps us be nice and neat. Then I'm going to alter that to oh dearie me, middle. We'll get there eventually. And we'll alter that to right. So we've now got 3 little boxes all set to number 2 for left, right, middle switch. So what we're going to do now is go down to the loop and we're going to add in a new command called if. And what I'm going to say is if digital read, so and you notice it goes red straight away, that's saying yes, I recognise that command, my left switch. So what we're saying is, and you've got to match your brackets up. What we're saying to that now is if it can see the switch, I'm doing things here and I'll come back and tell you what I'm doing. So what I've done now is I've put that program in another set of brackets, and what that does is that now isolates that, but because it's got the if command in front, it understands that that if command, that brackets now belongs to the if command. And if I touch that top loop, which is one of the other things I like to do, is I like to move my brackets over into the left column. Makes it easy to identify where they belong to. And if you notice, if I touch that one, it will automatically put a box around the bottom one. Touch that one, puts a box around the top. It basically tells you which bracket belongs to it. Wherever you touch the bracket, it'll say which other bracket belongs to it. So you can see easily that we've now got that software in. So what I'm saying is if that read switch is on, then run the motor. So let's see what happens. Program coming in, and it's still running because the switch is on. But as soon as I press the switch, which turns it off, then we know that the left switch actually is 2. If I touch the other 2, makes no difference. But that, as you can appreciate, that's not really the way around we want it. We want the motor to stop when it bumps into something, not keep. Which it is doing. I'm getting my logic wrong way around. So you can see now that what's happening is, as I touch that switch, it stops that piece of programming running, because it'll only run that program if the switch is on. So if that was running forwards, when that switch touched, that motor would stop. So we now know that that switch, whoops, and of course it only, if it starts and I hold the switch down, it will keep going because of the delays, because it doesn't actually, if the software, it doesn't come out of that loop and look at the if again as it goes round in the loop until it's finished those commands. So that's another reason why delays like that can cause robots to bump. But for what we're doing, it solves us problems. So we now know, looking that the right switch is actually pin 2. Okay, so we've already got it set as 2. So going back up to the software, we'll now say make my left switch 3, and then upload that program. So of course the robot is running again. But of course, this switch does nothing. So which are the other switches? So that does nothing. But if I hold the middle switch down, then the motor stops running. So, by that logic, the middle switch is 3 and the left switch is 4, because we know we put them on. But we'll prove it by running the program. So again, the robot's moving, but this time, right switch doesn't stop it, middle switch doesn't stop it, but left switch does. Right, so we've established using putting names on boxes and numbers in boxes where all our devices are, but we're actually working the wrong way around. If you actually look at the robot, really, although it is stopping the motor when we touch the switch, we're actually working the wrong way around, because in reality we want the motors to run and then the stop to happen instantaneously and literally reactive, as opposed to starting the motors. It wants to be stopping the motors. So we can come back in here now, and what I'm going to do is I'm going to literally start out first of all by copying that command and use that to blitz that, copy that command and use that to blitz that. So what we've done now is we've taken out the delays. Now if we were to run that, it'd probably hardly move the motors, because we were switching them on and switching them off so quickly. And then what I'm going to change the name on that to left motor, and that to left motor. Oops, trying out to capital E. You have to get the words absolutely spot on, otherwise it will complain to you when you try and compile them. It'll say it can't find the variable. So we'll now send that to the robot, which what that should do now is bring on both motors, which should, as it compiles, it'll now upload it, which it stops. So now we've got both motors on solid, because although it's switching them on and off, it's switching them on and off that fast that it can still see some electric, but they're not going at full speed. If you notice, this is sort of a half speed, which is where pulse width modulation comes from, because we're now switching the motors on and off that fast that it can still see power, and so it carries on. But what I want to do now is I want to now take those commands and place them in there. So what's happening now is we've basically got a situation where in the setup the first thing it does is start the motors, and just so as it doesn't scare us to death while it's in its hands, if I can spell it right, I'm going to put a 10-second delay in between the program starting and the motors coming on, so that then we'll get rid of those commands. So we're now left with a situation that the switch, when it's pressed, should turn off the motors. Send that across. So, first of all, we get our 10-second delay, which will be an exact 10 seconds. And nothing happens. There's a reason for that, because one of the things that we've been doing all along, which wasn't necessarily obvious because you're new to programming, is that if statement there was only working when we pressed the switch. So what's happening is it was only switching the motors on when we pressed the switch. So what's happening now is the motors have been come on for a microsecond or two and then instantly been switched off, because of course that switch is always on. And what we're saying is, if it's on, then do this. And what we're saying, if we actually extend that statement, if we're saying that equals to 1, and you've got to put the equals twice because that if you put it once it would make it 1. If we now send that program over, just to prove the point, that is exactly what we've said. So the software's gone across, we have our 10-second delay, and the motors don't start. But they have started. And if for sheer interest, I actually put a delay of 1 second behind that setup command, just to prove the point, what will happen is the software will go across, which is uploading now. You can see the lights flashing. We'll have our 10-second delay. The motors will run for a second and then stop. Because the way we set these switches up was so that they only work, they only actually really sense, or the way that we want them to sense, is when that switch is closed, that and the LED goes out, which is 0, that's 1 binary, that's 0 binary, that's when we actually can detect the switch is closed. Otherwise they're open all the time. So going back to the software, what we have to do is alter that to not equals to, and what we call in the UK an exclamation mark, and the States you call it a shriek, is saying not equals to, which is why there's 2 parts to that thing. You can the first half you can actually say more than you can actually add extra conditions, so that instead of it just being equal to, you can say less than, greater than, or not equal to, which is what I just said there. So if we now run that and send that across to the robot, we'll find that that now is doing what we want it to do. Second delay. Sorry, should have put a shorter delay in. So now that's running, and when we touch the left switch, it stops. And it stays stopped. So why is that? We've let go of the switch. It's still stopped. Why is it still stopped? Because if we go back to the actual software, if we get the right button, in that loop there no longer is a switch on. So basically, what we've done is we've shown how we can start the robot and get it running, and we'll get rid of that delay just for keep it tidy. I'll drop that down to 5 seconds just for this thing. It's 10 seconds when I do it properly. For now, we'll take 5 just for speed. We're not actually switching the motors back on. So if we wanted the motors to come back on, we could then take that statement and add it outside. So what we've done is we've now added that outside the loop, so that it's going switch on, switch on, switch on, and it only switches off when we actually touch that switch, which will show you that. If I press load, so what we've got there, now see, if you notice the speed's gone down, because that's the problem. Although we're switching that motor off, we're actually switching it off half the time as it's running through the program, and then it's switched back on. So I want to just quickly show you that, just so you can see how easy it is to have things that look like they're going to work but don't work. So we'll delete that out, and then what I'm going to do is I'm going to add an extra command. And one of the things you can say, because at the moment we're only looking at one switch, I'm going to copy that out. If I can get hold of it, I'm going to copy that out. This is supposed to be quicker than typing, but the mouse is a bit sensitive. And again, and then using the fact that we've got everything named, I'm going to say middle, and then I'm going to alter that over there to right. So what I've done there, the OR command sees that now as 3 separate if statements all in one. It goes if that, or that, or that. And so what that allows us to do is, if any one of those 3 switches is pressed, it should turn the motors off. So we'll send that over to the bot. And we've got a 5-second delay. And off it goes, and sure enough, as soon as a switch is stuck, the robot stops. Now then, I don't want to start going into anything further at this stage, partly because this has been a long enough tutorial for anybody to watch to start with, and secondly, you can then spend hours and hours sitting down and working out your rules. But it just proved the point that what we've got there is a nice little robot that will run until it bumps. And so what I'm going to do is I'm going to actually take it off the computer. We'll go to the arena, and we'll actually see what happens when what I'm going to do is I'm going to, let me come across to me for a second, I'm going to actually press the reset on there. We'll go over to the arena, and we'll put our little robot in the arena, and let's see what happens, just to finish this video off. And although it hit there with some force, it did stop the motors. So really, with all the programming we've done, we've got a little robot that does nothing more that runs, but at least it doesn't bash into the wall and keep bashing into the wall, don't beat its brains out. We're really at the beginning here, but what we've done now is, just to summarise, we've identified all our controls, we've identified as motors, we've identified as switches. So the next video, and the next tutorial, will be how to take those commands and literally start building the intelligence of the robot so that it does things sensibly. And I'll go through that in the next tutorial.